If you've been on Reddit or Twitter recently, you've probably seen people talking a lot about AXUM. And some people are even calling it the best Rust web framework ever to be created. Now, it's on the GitHub repository, it says that it's a relatively thin layer on top of Hyper. Hyper is another light HTTP client that already exists. And on closer inspection, you see that AXUM is hosted with the Tokyo RS repository. Now, Tokyo RS is something that we've already seen in one of the previous videos. And AXUM is built with Tokyo Tower and Hyper. So it's fairly lightweight. It doesn't have a lot of features. And if you actually think about it, if you are new to Rust and you wanted to build something like a complete web server, using something like ActixWeb would be a lot of commitment, in the sense you would have to completely commit to Rust and you'll have to learn a lot of the features, because ActixWeb comes with a lot of features, right? And AXUM is quite lightweight, very easy to get started with, very easy to start, build something end to end, and yet it doesn't break. It's not like it's a shoddy library. It has the features that you need, the absolute essential features that you need. At the same time, it doesn't burden you with too many features, and it's a very lightweight documentation as well. So if you go through the documentation, it doesn't try to confuse you. It just has just the basic stuff. So today's video is all about AXUM. I'll show you how to build a nice little project with AXUM. Okay, so let's get started. This video is going to be a part of the 50 Rust project playlist series on my channel. And I have these 50 Rust projects, and then also I have 55 killer Golang projects. The idea is that these are projects in the increasing level of difficulty. All of them are for free. Make sure you subscribe and share this with your friends, because this is awesome content. You can become a Golang and a Rust developer by just following through these projects, building along with me, and you'll be really good by the end. Apart from this, I also have the Technical Architect course, the Ultimate System Design course, and the AI LLM project series that I'm building up right now. So make sure you check out all of these. Now let's get started. Now, as you can see, I'm using Docker Compose, and I've started off my Postgres and PG admin and Docker containers. And my Rust will now be able to easily talk to Postgres, right? And I'll share this Docker Compose file with you. Now, as you can see, I've also run cargo run, and then my Rust server is running, and it's connected to the database. Now, I have my Postman collection. So let me bring that up really quickly. Yeah, so now I can play with those REST APIs, and I'll just do a health check. So it says everything is working perfectly fine. And then I'll create a note. So I can create a note like this. So note with that title already exists. So it has a little bit of validation as well. So I'm going to change the title of the note, and now it's created the note for me. And then I can get a particular note. Right, so note with that ID not found, so I'll have to see what was the ID returned for my note. So I'll just check that here. I'll just put that here, and then it's able to fetch the particular note for me, and then I can delete it as well. So I'll just put it here, but before that I'll quickly update it, because I don't want it to be yeah, so I've updated it now, and now I can go ahead and delete it. So it's deleted, right? So everything works perfectly fine. Let's see what all notes are there from previously. Yeah, there's one note that's still there from before. So we also have the get all notes API as well. So we have a few APIs that we have to build using AXUM, and this was a quick demo. Now it's time to start writing the code. So we'll create a new project with the help of cargo new, and I'll call it AXUM Postgres YT for YouTube, and I'll cd into it, and I'll open it up in my VS Code. So it's created the cargo.toml file for me, and I also have the main.rs file. So here I'm going to have 4 more files. I'm going to have the handler.rs, I'm going to have the model.rs, the schema.rs, and the route.rs. These are the few files that I need. I'm going to shift all of these into the src folder. Now in my main file, right? In my main file, I need to get all of these other modules, right? That's how, because main is like at the center of all projects, and that's where you want to have all the other modules. You want to have the module handler, you want to have the module for the model, right? All the modules that we created right now, and then you have your route and your schema as well. Okay, so you have all of these, and now what you'll do is you will get sync arc, and we'll soon see why. But before that, before I start writing any other code, I want to get AXUM. That is the most important thing in this project, because we're using AXUM to create our APIs. And I'll have to put something in the brackets right now. I'm gonna leave it empty, and I'm also not gonna get any other package for now. Actually, there's one that I would need. I would need the SQLX one, SQLX, and I need, because I need Postgres connection, I'm going to say pg pool options, comma pool, comma Postgres. All right, so I need SQLX, and I'll also have to update my cargo.toml file, because I'm using like AXUM and SQLX and Serde, .env, GetNote. Okay, I'll use all of these packages, and and one by one, when we start using these, you know this is for Postgres, you know this is for the to create the APIs, and one by one we'll start using all these packages, and you'll know why we're using these. So in our main, firstly, this is Tokyo main, because I want this to be async function, so I'm gonna make this function async. Okay, and now that I have Tokyo here, what I'll do is I'll also read the .env. Okay, and if I'm doing that, then I would also need to get it here. So I'll say here use .env .read. Okay, and the first thing that I'm going to do, I'm going to get my DB connection. So I'm going to say env var, and in my env there will be the database, right? So the database underscore URL dot expect. I'm going to say database URL must be set if there's an issue. So that's our database URL. Now we're going to be working with Postgres, and like I said, the main function will have all the connection logic, but the routes we're going to build in our route.rs file. We're going to have the model for the note in model.rs, and schema is for the validation side of things. Like for example, what if somebody's sending a create request, a post request for creating a note, or a patch request for creating an update, then what is the kind of object they'll be sending. So all of that I'll define in schema.rs. And my handler is going to have all the logic, because the routes are going to define the routes, and they're basically going to transfer all the control to the handlers. So handlers will have a lot of the logic. And before I continue in main.rs, because I've got my database URL now, and I have to do a couple of things here. Before I do that, what I'll do is I'll just create my model.rs, and actually I'll just copy and paste it very fast from here. Right. So as you know, I've already built the project. It's there on my GitHub. What I'm going to focus mostly on in this video is trying to explain everything to you, so that even if when you look at the code, everything makes sense. All right. So we are going to be using SQLX, as you know, for the database. So that's why we had to import it. And this is what the note model will look like. So we're going to have the ID, the title, the content, the category, and published yes or no. That's the Boolean. And then you have for created at, we're going to use chrono, created at for the time, and updated at, we'll use the same thing as well. Now in the schema.rs, what I'm going to do is I'm going to be putting a few things there, right? Will help me with validation. So I'm going to have my filter option. So when I get the list of all the nodes in the database, I'm going to be using page and limit. So that's why I have the filter options defined as a struct. because I'll have clarity on how the filter options need to look like. So at least my Rust code will understand. And when I am going to have the ID sent in the params, like to retrieve a particular note or to edit a particular note or to delete a particular note, I'm going to have ID sent in the params. This is why the params option going to look like this. When I'm going to send a post request to create a note, it's going to have the title, the content, the category, and published. Notice it doesn't have what we defined in the model, which was the created at and updated at, because that's something that we'll do, right, in the code, and we're not going to take it from the user. So we don't expect the user to send updated at and created at. That's something that we are supposed to do. So that's why we don't have that here. This is for the validation of the object that the user will send when creating a node. This is the validation for the object the user will send when updating a node. So he's going to send the title, content, category, and published. Right? These 4 things is what he's going to send to us. So that's the schema. That's the model right there. And then you have your main.rs. And before I talk about main.rs, I'm going to talk about the environment file, because because we are reading from the environment file, but we don't have an environment file. So we need that here. And what all does it have? It has the Postgres host, which is localhost, the port is 6500, the Postgres user admin, password 123, password 123, and the database name, the database URL, and the default email and default password. Okay. Now that we have all these things, I would like to create a Docker compose.yml file. In this file, what I'm going to do is I'm going to write everything that's required to create my services for my Postgres and my pgadmin. So these 2 services will be created. Now Postgres is getting created from an image called Postgres latest. Container name will be Postgres. And similarly, pgadmin is getting created from an image called pgadmin4, and container name is pgadmin. The port 6500 is running, and it's ported. It's mapped to 5032. And it's running on 5032, the Postgres, and it's mapped to 6500 because that's where we're expecting it to be. If you look at the main.rs and the environment, so we're expecting it to be on 6500. That's what Rust is concerned with. And we have a volume, and we're reading from the environment file also, all the other things, right? Similarly, pgadmin environment file and port is 5050. All right, I have my Docker Compose file complete. So now I can come back to my main.rs. And in my main.rs, I had created the database URL, right, which will help me to connect to the database. Now, when we want to connect to the database, how do we do it? We use Postgres Pool, because in this particular project, we're using Postgres. So we're going to use Postgres Pool. And the way to do it is we're going to match our Postgres Pool options, and we're going to capture that in a variable called pool, and that's the one that we're going to pass around in the rest of the project. Okay. Now there are more options that exist with the Postgres Pool, which is that we have max connections 10, and we're connecting to the database URL that we just created here. And if everything goes fine, we're going to say connection to the database is successful. If it failed to connect, we'll say failed to connect to the database. Okay. So what am I going to do with the pool? Now, what I usually do, and I've done this in previous projects also, if you've seen the projects, the other Rust projects, what I usually do is I create something called as the app state, right, which holds the connection to my Postgres database. And this app state is what I pass around between the routers and the handlers and all of that. So everybody will have access to my app state depending on whom I pass the app state to. Okay. So what does the app state look like? So app state is nothing but just a struct called app state. It just has access to the database pool, which is Postgres. Okay. That's what I usually do. Now, yeah. So I'll come here now. Okay. And the next thing that I want to do is I want to think about course errors, right? So 90% of the time what will happen is when you create a server like this, like a backend server Rust project like this, you would have something like React.js that will be calling the APIs from this server, and you'll end up with course errors. So even though we're not building a React server, React front end right now, I'll still put in some logic that'll help me avoid course issues. So it's going to say allow origin from localhost 3000, so allow requests that are originating from localhost 3000, and all these methods are allowed. So get, post, patch, delete, these 4 methods are allowed. Credentials, allow credentials true, allow headers, authorization, accept, and content type. Now if you see here what I'm using something called as course layer. Okay, and I don't have it. I don't have anything called course layer yet. But I'm going to get it. I'm going to get it now. So this is what course layer is. It's coming from this micro HTTP package called the Tower HTTP. So if you remember, I showed you, the first thing that I showed you about AXUM was that it's dependent, or it's actually being built upon 3 different frameworks. So it's using Tokyo, it's using Tower HTTP, and it's using Hyper HTTP, which are 3 small HTTP packages which it's using, and then it's pulling in all the functionality from it, and then it's building on top of that. So that's AXUM. So what do I need from AXUM? I need these things from AXUM. I need the header and header value and method. Why? Because now I'll create my server. So the first thing before I create my server is that I'm going to create my app. So this is what my app does. It is going to use create router function, okay, and going to have the app state, what I've just showed you, which is the DB pool connection. So app state, and now create router, right? So what is create router? Create router is basically from my route package. I have create router, so I've gotten that as well now. And when all of this is fine, then I'm going to say server started successfully, and then I'm going to create my listener. So I'm going to have a listener running a TCP listener with the help of Tokyo. You remember Tokyo, Hyper, and Tower is what AXUM uses anyways. So we bind on the 8000 port, okay, with the TCP listener, and now I can use my AXUM. Okay, so I have AXUM here. I just imported AXUM here on top, and I'm going to use the AXUM serve function to create the listener and pass my app. So it's on 8000. The app is being served, and yeah, so my server will start with this. So my main file is done. I'm going to go ahead and save it. So main file is done. Docker Compose is done. Model is done. Now I want to work on the route.rs file. So in the route.rs file, the first thing that I'll get is my AXUM. And even before that, I'll get access to my arc, sync arc. And then I will get my handlers. So I haven't created these handlers yet, but the idea is that I'll create some routes, and then when I hit those routes, those handler functions will be called. So for example, I'll have the CreateNote Handler, the DeleteNote Handler, the EditNote Handler, the GetNote Handler, Health Checker, and NoteList Handler. And as you can see, I'm passing the app state like I had mentioned. All right, so now I'll create my router, which is my create router function, which if you remember, I just called that in my main.rs file. I called my create router function, and that basically also has access to the database, and the app state. But that's the one that's responsible for creating all the routes and then calling all these handler functions. So when we start our application, which is basically starting with the help of AXUM serve, you're passing the app. The app is using the create router function, which we're creating basically all the routes here. And here I'm going to say router new, and router is coming from AXUM, as you can see. Okay, so I say router new, and then I just paste in my routes. So I'll have multiple routes here. So for example, I have the health checker, which is going to use the get method to call this function, which is the health checker handler function, which I'll have to create in the handler file now. Then I have my API/nodes, which is going to call the post method on the create node handler function. Then /API/nodes is going to get all my the complete list of all my nodes. And then I have some routes for /ID, which is getting that particular node, editing that node, and deleting that node. And everything is happening with the help of app state. Okay. Now, yeah, this looks all right to me. Okay. So this is our router.rs file. And now we have to work with our handler.rs file. This is where all the logic, like working with the database, is happening. So again, I'll let me first get all the crates. So I'm going to obviously have AXUM, I'm going to have Serde, I'm going to have Arc. And in case you don't know how Serde works, I've covered this in multiple videos, the ones in the beginning, the easier videos. So this is like serialization and deserialization with JSON. And we are going to use our note model. So we created a note model in model.rs file. This one is what we need because we're working with a database. So we need all the things like the models and the schemas, all those things here. So we got our model and we got all the schemas from schema.rs file. And obviously we have access to our app state. Now I'll have to start function by function. So first thing I need is the health checker handler, because that's the first thing usually that you would call when you would start off this project. So the health checker handler function is just going to have this message, which is simple CRUD API with Rust, SQLX, Postgres, and AXUM. And when I used Postman and call this API just to show you the result, this is what we got in the output. And in all these functions, all the handler functions, this will be common, which will be our JSON response that we'll be sending back from the function. So our JSON response will be using Serde JSON, and we'll have a status and a message. In this case, the message is just this. It's very simple. Okay. And now we have our note list handler, which basically means that we're gonna show the complete list of all the notes in our database. How are we gonna do that? We're going to have this function called note list handler, which as you can see here, it's here, note list handler. And it gets called when you hit the route /API/notes with the get method, and you'll hit this function note list handler. This is going to return the list of all the nodes in the database. Okay, so it's going to have query options, which is going to have the limit and the page, because when we're returning all of these, we just have a little bit of pagination here, limit and page, because we're returning all the nodes, the list of nodes. And then we create our query. So our query, with the help of SQLX, this is what it looks like. So we have our select star from nodes, order by ID, limit, and offset. So when you have $1, $2, you're essentially replacing it with these values, limit and offset, which is I32 and I32. Okay. So this is what we're creating. We're creating a query, a Postgres query, which is going to be run with the help of the SQLX package in our database. And what we'll get back from the database as a response will be our query result, the result that we'll get. Okay. And when you say fetch all, you'll either see this fetch all, or in others, other functions that we'll create, you'll see something called as fetch one. It's going to fetch all the values that are returned basically. So you get that in query result. Now, if the query result has an error, we're going to have this message that we'll create will be status is failed, and message is something bad happened while fetching all node items, and you're going to return this error status code. Then otherwise you're going to have you're going to create you're going to have this query result, and you're going to capture it in this variable called nodes, and you're going to create a JSON response. So you have the status success, and you have your results, right, which is how many, basically the number of nodes that were found in the database, which is nodes.length, and the nodes themselves. So you create a nice little JSON response, and you'll send back that response from this function. So all this function really does is send back the list of all the nodes in the database, and it does that by just calling this function, just this query. So all you're getting to do is, with the help of SQLX, you're able to call or create Postgres queries and run them in the database. That's what you're able to do. The next function is the create-note handler. So the create-note handler is something that helps you create a new note, and that's what you see here. And if you hit the /API/nodes route with the post method, you will enter the create-note handler function, and this is what it looks like. It's gonna accept the state, the app state that we have created, and the JSON body, because when we create a new note in the database, we need the data of the note in the body that we send, the JSON body, the request that we send, and we get back the status code and the value. So let's see how this function works. So we create a query first, right? So as you saw, this is how you use query as, and you create the query, then you run it using the SQLX package, and then you get back some query results. So the query that we are running is insert into notes, title, content, and category, the values 1 to 3. So $1, $2, $3. That means, and returning everything. So $1 you got it from the body request body that you've accepted has a value called title, and the body also has a value called content and something called as category. So these three things will be replaced here in $1, $2, $3, and we'll get this query. This query will be run with the help of SQLX query as, and you'll get fetch one. So you see here fetch one, that particular node that was just created, and that will be in the query result. If everything was fine, you will say status success and data is JSON and note that you will show here, and you'll say it was created. But if there was an error, you're gonna say duplicate key value violates unique constraint, and status fail, note with that title already exists, and you'll return back a issue. Okay, and then you'll if the error was nothing to do with duplicate key values, then you're just gonna say internal server error, and there was this error. So that's what our GetNote Handler is doing. All right, so now the next function is going to be the GetNote Handler. So you're gonna have a particular ID, and you're gonna get the note that has that particular ID. So let's do that. Let's see how that works. And that function is also getting used here when we so these are the three functions that are left now: the GetNote Handler, the EditNote Handler, the DeleteNote Handler, and they're all getting run by these different methods. So for example, the get method, the patch method, and the delete method. And yeah, so now we're working with the GetNote Handler. So we're passing the ID of that node that you want. So this is the GetNote Handler now. Let's look at how it works. So we're gonna accept the ID, we're gonna accept the data as well, which is the app state. So now we'll create our query. The query is basically select star from nodes where ID is $1, and ID is going to get replaced by the ID that's been passed to this function, and you get back that in the query result, and you fetch only one of those values which has that ID. And if everything was all right, then you'll say success, everything is fine, and you're going to return that particular note. And if there was an error, and you'll also return that JSON response from this function. But if there was an error, you'll say fail and note with that ID not found, and you'll say send the status code not found. Okay, so that was your GetNote Handler. And now you'll have your EditNote Handler and your DeleteNote Handler. So I'm gonna first create the DeleteNote Handler because that's like much simpler. So DeleteNote Handler is something that is you run this function when you use the delete method on this route by passing the ID of that particular node that you want to delete. So how does it work? So DeleteNote works like this. You are going to pass the ID and the app state. And then what we have always done, we've always created a query, which is in this case delete from nodes where ID is that particular ID. And you're going to use the SQLX package to run this query, and then you're going to execute the delete command on the database, and you're going to get the rows affected. So if there were no rows affected, in the sense like nothing was deleted from the database, you're going to say status fail or status failed, whatever, however you're going to pronounce it. And you're going to format that node with ID not found. And then you're going to also say status code not found. And finally, but if you were able to delete it and we didn't enter this if code block, then we're just going to say status code no content. That means everything was fine. We've deleted the particular node from the database. The final function that's left is the EditNote Handler. So I'm going to go ahead and put it here, EditNote Handler. And that's the one that's getting called here with the patch method, EditNote Handler / API node / ID. Okay. So EditNote Handler, how does it work? It accepts the ID and the state and the body, and then you create a query result. So you're going to say select star from nodes where ID is this, because when you want to edit something from the database, you also want to check if it exists in the first place, right? So we'll check if it exists in the first place. And if there was an error, we're going to say fail, node with that ID not found. And then because we want to update the values of that particular node, we also going to need now, because that's updated at is the field that we'll have to update as well, because now we're updating that particular node. So we'll also be updating something called as updated at, the timestamp. That's why we need the now chrono library. And we're going to capture the query result from this query in this variable called note. Okay. And now we have our second query result. We have the particular node, but now we're going to use query result again, which we have already used it before. We're going to use it again with the second query. The second query is now about updating. So we're going to update the node and set the title, content, and category published, and update it at where ID is this. Okay, so ID is going to get replaced there. So whatever ID you passed in this function, that particular value will get now updated, and we'll replace the title, content, category published, and the timestamp which is updated at. All of these will be updated. Okay, and we'll also fetch that. So when we were able to fetch it, we'll say everything was fine, success, great. But if we weren't able to fetch it, we'll say null server error, something went wrong. Okay, so that's our handler.rs file. So we have everything now: the schema.rs, route.rs, handler.rs. All of these are complete. We have our environment file as well. We also have Docker Compose, and we have updated everything in our cargo.toml. So what I'm going to do is I'm going to go ahead and try to run the Docker Compose file. So I'm going to say Docker Compose up -d. Okay, so the container PG admin is already in use. So what I'm going to do is because these containers are already running from before. So I'm going to say sudo docker ps, and gonna get the list of all the containers that were running before, and I'm going to delete them. So I'm going to say sudo docker rm. The name, what's the name of this container? I can't see the name of the container. I'm just going to put in the container ID instead. rm, and then the container ID, and then the another container ID also I'm going to put there. Oh yeah, now I can see the names also. I can see the names Postgres and pgadmin. Anyways, so I've removed these two containers, and then I'm going to just go ahead and say docker compose up -d. So it's running, and now what I can do is I can run cargo run also. I might get some errors, but I'll fix those errors, not a problem if I get any. But now I can do cargo run, and it's going to use my pgadmin and Postgres to start the server for me, the Rust server for me. So I'll wait. It'll take me about like a minute or so. So I'll wait a while, come back. Now I've run my program, and I've got a few errors here. Now it's possible that all of these errors are because of just one reason, which is relation notes does not exist. That means the table called notes does not exist in my Postgres. And or it's possible that there are other errors because of other reasons as well. But we can only find out once we fix this particular issue, which is the notes table not being there in my Postgres. There are multiple ways to do it. As you remember, there's the PG admin that's running on port 5050, right? Because if you remember, our Docker Compose file starts off a PG admin on port 5050, and the login for the PG admin is here, which is the default email and password. So you could go ahead, you could do that. You could log into your PG admin and create the database and table. What I have done, I have just simply done it from the terminal, right? So I used PSQL. I switched to another user, switched to PSQL, and then I created my database, Rust SQLX, and I switched to the database, and then I created a table. Now, when you try to create the table, so I've kept these commands for you guys on GitHub, right? Which is in the migrations folder. You'll find that you can run this command. You just have to copy and paste this and run this in your Postgres. But before that, you also want to add this extension, which is UUID OSSP, because this is otherwise you'll get an error out here, UUID. So I've just get that extension also. That's why I've done create extension if not exists. I've run that command first, then I've run the create table command, just copied and pasted from the file that I just showed you. And then I have my table now. And now I can just exit this. And I'm back to my user on the desktop, and I can cd into the project, and I can say cargo run. Let's see what happens now. Okay, so now am I getting that issue again? No, I'm not getting that issue again. I'm getting something else now. So let me try and fix this as well.